Let's solve the following system of linear inequality. We'll begin with the first inequation. So here we are given 2x plus 1 divided by 7x minus 1 greater than 5. So we'll transpose 5 to the left hand side. We have negative 5 greater than 0. Let's combine these two terms. So in the denominator we have 7x minus 1. In the numerator we have 2x plus 1 minus, we have 5 multiplied to 7x minus 1, so that gives us 35x plus 5, which is greater than 0. Solving the numerator, we get negative 33x plus 6 divided by 7x minus 1, which is greater than 0. Now we're going to multiply the numerator with negative 1. So we also have to multiply 0 with negative 1. So let's multiply with negative 1. That gives us negative 1 multiplied to negative 33x plus 6 divided by 7x minus 1. And this when we multiply with a negative number, the sign of the inequality changes. So here we are using the fact that if, let's say, we have two numbers a and b, a is greater than b, and we also have another number c, which is a negative number, c is less than 0, then if we multiply a with c and b with c, the negative number c, then the sign of the inequality changes. That means AC will become less than BC. So we'll use this fact, and this is going to give us 33x minus 6 divided by 7x minus 1. This is less than 0. Now to find a solution to this linear inequality, all we have to do is find out some critical values. So critical values means the value at which the numerator and the denominator goes to 0. So we'll equate the numerator, which is 33x minus 6, to 0, and we'll also equate the denominator 7x minus 1 equals to 0. So that gives us x equals to 6 over 33, or simply 2 over 11. And 7x minus 1 equals to 0, solving for x gives us x equals to 1 over 7. Now 2 over 11, so this is approximately 0.18, and x equals to 1 over 7, so this is approximately 0.14, meaning 1 over 7 is less than 2 over 11. Now we will do is consider a number line. On the number line, we will take these two critical values. So we have 1 over 7 and 2 over 8. Right. Now what we'll do, we will take some values of x. We will consider three values of x. We will consider x to be equals to 0, with choosing the value such that the value of x equals to 0 is less than 1 over 7. We will consider value lying between 1 over 7 and 2 over 8. So we will consider x to be equals to 25 over 144. To find this value, all we have to do is add 1 over 7 and 2 over 8 and divide by 2. So this is going to give us a value exactly between them, which is 25 over 1 over 44. And we'll consider a third number, which is greater than 2 over 8. So let's take 10. Or we can even take 1. So we will consider x to be equals to 1. That will help our calculation. Fine. Now what we'll do, once we choose this value, we are going to substitute into our rational expression, which is 33x minus 6 divided by 7x minus 1. So let's note it down. So we have our expression 33x minus 6 divided by 7x minus 1. Right. So for x equals to 0, we'll have negative 6 divided by negative 1, which gives us a positive value. So that means for values of x less than 1 over 7, we get positive value. Then for a number lying between 1 over 7 and 2 over 8, so we will substitute into 33 over x. So x will be substituted with 25 over 144 minus 6 divided by 7x. So 7 will be multiplied to 25 over 144 minus 1. And this is going to give us minus 39 over 31. So that means we're getting a negative value. And finally, for x equals to 1, we'll get 33 multiplied to 1 minus 6 divided by 7 times 1 minus 1. So here 33 minus 6, so that's a positive value, divided by 7 minus 1, which is 6, which is also a positive value. So that means this will get a positive value as well. Now, if we look at the inequality, so here we have to find the solution or the values of x which makes the expression negative. So that means this is the only region where we will get a negative value. So the solution to this linear inequality will be going from 1 over 7 to 2 over 8, and it will be within open interval because the endpoints are not part of the solution. So now what we'll do, we'll try to solve the second linear inequality. So we'll begin by transposing 2 to the left hand side. So this gives us x plus 7 divided by x minus 8 minus 2 is greater than 0. So let's combine them. We have x minus 8 in the numerator. We have x plus 7 minus 2x plus 16 greater than 0. So x minus 2x will be negative x plus 7 plus 16 will be 23 divided by x minus 8 greater than 0. So we will multiply the numerator with negative 1 and we'll multiply 0 with negative 1, and this is going to give us x minus 23 divided by x minus 8. But since we are multiplying with a negative number, we'll have to flip the sign of the inequality. So this will become less than or equal less than 0. Right. Now we'll find the critical values. So the critical values will be, we will have to equate the numerator and the denominator to 0. So equating the numerator to 0, so this gives us x equals to 23, and equating the denominator x minus 8 to 0 gives us x equals to 8. Fine. Now what we'll do, we'll consider a number line, and on this number line we'll have 8 and 23, and we'll consider three values. We'll consider x such that it's less than 8, so we'll consider x equals to 0. We'll consider the second value as a lying between 8 and 23, so we'll consider x to be equals to 10, and we'll consider a third value which is greater than 23, so we'll consider x to be equals to 30. Now we will substitute each of this value into our expression, the rational expression x minus 23 divided by x minus 8. So that means we have 0 minus 23 divided by 0 minus 8. So here we have a negative number divided by a negative number, so that makes it positive. So that means we have a positive values for values of x less than 8. Now let's consider x to be equals to 0. So here we have 10 minus 23 divided by 10 minus 8. So 10 minus 23, so that's a negative value, which is negative 13 divided by 10 minus 8, which is 2. So that means we are getting a negative value for x lying between 8 and 23. And finally, we're going to consider x equals to 30. So here we have 30 minus 23 divided by 30 minus 8. So 30 minus 23 is 7. 30 minus 8 is 22. So this is a positive number. So for values of x greater than 23, we have positive values. But if we look at a linear equality, we'll only have to consider that value of x such that the rational expression becomes less than 0. So we have this particular region which is 8 and 23. So it starts from 8 and goes all the way up to 23. Now our final goal will be to find a common solution between these two intervals. So let's do that. So we'll begin by considering our real number line. On the real number line, we'll have the while x equals to 1 over 7, x equals to 2 over 11, x equals to 8, and x equals to 23. So here we have our solution. For the first linear inequality, we have a solution lying between 1 over 7 and 2 over 11. And for the second linear inequality, we have a solution lying between 8 and 23. So clearly, we see that there is no overlap of solution between the two inequalities, the solution of the two inequalities. So that means we do not have any common solution. So since there are no common solution, we can say that the given system of linear inequality has got no solution.